So there's a couple things that come up on problem 15 on our homework that I wanted to go over. First of all, I'm hoping that you'll recognize that this problem is a binomial problem. It says that a random sample, it doesn't say random, but a sample of 16 babies is studied. And among baby boys 6 to 8 months old, 30% of them weigh more than 20 pounds. So we're going to call 30% or 0.30 our probability of success. And so we want to know, if we select 16 babies, what is the probability that 6 of them weigh more than 20 pounds? So what is the probability of having 6 successes? Once you know that there's 16 babies sampled and the probability of success is 0.30, there's a number of ways to get that answer. Without calculation, the way to get the answer is to go to the tables that they have for our book. And the first table is a table of binomial probabilities. And you see values of n listed over in this far column. So we want to find the column corresponding to n equals 16, or the part of the table corresponding to n equals 16, which is right here. So all of our possible answers for n equals 16 are going to be here. And then we want the column for the probability of success equal to 0.30, which is here. So in the section for n equals 16, we're going to be in the column for p equals 0.30, meaning all of our answers are going to be in this column here, depending on the various values of x. Speaking of which, there's 6. So when n is 16 and the probability of success is 0.30, the probability of 6 successes is 0.165. And because the table shows the answers to 3 decimal places, that's why they've asked up here to round answers to 3 decimal places. There are a number of other ways to find that probability. If you're in Excel or in Google Sheets, either one, there's a binomial distribution function built in, binom distribution, and it wants the number of successes, which is 6. It wants the number of trials, which is 16, and it wants the probability of success, which is 3. I don't know if I need to say the cumulative or not. I guess I do. Probability of success is 0.3. I'm saying false because I don't want this to be cumulative. And there's the same 0.165 that we got before. Also, there's any number of binomial probability calculators online. The probability of success, 0.30, the number of trials, 16, and the number of successes that we want the probability of is 6, and calculate, and it tells us there's the 165, which is the probability of 6. Then it also tells you the probability of less than 6, the probability of less than or equal to 6 successes, the probability that we have greater than 6 successes, or the probability we have greater than or equal to 6 successes. So every probability we could want related to binomial probabilities is spit out by this. But anyways, we want the 165 for this one. Then part 2 says, what is the probability that more than 5 weigh more than 20 pounds? So what is the probability that you have more than 5 successes? Well, that could be rewritten several ways. That's also the probability that you have greater than or equal to 6 successes. So if you have more than 5 successes, you've had greater than or equal to 6 successes. And I could also write this as a complement having greater than or equal to 6 successes is the complement of having less than or equal to 5 successes. So there's a number of ways to do this. If you're stuck to doing it on the table, this is kind of why I rewrote it as a less than. You can say that the probability of less than or equal to 5 successes is the probability of 0 successes, probability of 1 success, probability of 1 success, probability of 2 successes, probability of 3 successes, probability of 4 successes, probability of 5 successes. Add all those together and subtract from 1. That's kind of the, I guess I would say, kind of the old school way of doing it. And the probability that the number of successes is 0, all of these probabilities are going to be really close to one another on this table. So the probability of 0 successes is this 003 number. This is 0.003. And the probability of 1 success is this, the probability of 1 success is this 023 number. The probability of 2 successes is this 073 number. The probability of 3 successes is this 146 number. The probability of 4 successes is this 204 number. And the probability of 5 successes is this 210 number. So if we add all those together, let's see what we get. And 146 and 204 and 210. That adds up to 659. And so if we subtract 1 minus 659, we get 341. So 341 is the probability that we want here, right there. Now there's a variety of ways of getting that also. This 659 number we can get on the calculator by saying second vars and binomial CDF. CDF, the C for cumulative, 16 trials, probability of success 0.3, and we want to put an X value of 5. This will give us the sum of the probabilities up to and including 5 successes, and there's the 659 number. Now technically that rounds up to 66, but there's the 659 number. On other technology, we can change this to a 5 and then change the cumulative flag to true, and there's the same 659. And if you go over here to my binomial calculator I was showing you, less than 6 successes is the 659 again. So there's a whole bunch of ways of getting the 659, and subtracting that from 1 gives you 341, but there's the 341, rounded off a little bit differently, but there's the same 341. So there's a bunch of ways of getting that one, either via technology or via the table. Then we have a question that says, what is the probability that the number of successes is fewer than 5? So fewer than 5 means less than or equal to 4. So again, we can add together several probabilities to find that. We can say the probability that x is 0 plus the probability that x is 1, 2, 3, 4. Add those probabilities together. Whether you get those probabilities from technology or from the table, it's just an addition problem. So probability that x equals 0, well, I've got a bunch of them right here. This is the 0 and the 1 and the 2 and the 3 and the 4, and that's all I need. So if I add those together, that'll give me my answer. So that's the same sum that I just got done doing up here, except I don't have the 210 at the end. So the sum of all those probabilities is 449. But also, I could have got that by using binomial CDF, second bars, binomial CDF, 16 trials, probability of success 0.3, and an x value of 4. This will give us all the probability up to and including 4, and there's 449 again. Or in other technology, with the cumulative set to true and the x value of 4, there's the 449 again. So a bunch of different ways we can get that 449. Oh, on this other calculator here, if I change this to a 4 and recalculate, less than or equal to 4 is 449. So there's a bunch of ways of getting that 449 number. And then they ask this question: would it be unusual? Would it be unusual if more than 4 of the babies weighed over 20 pounds? Would it be unusual if the number of successes, I'm going to write it like that, if the number of successes were more, would it be unusual if we had more than 4 successes? Well, to answer that question, what is the probability that we have more than 4 successes? That's the probability of having greater than or equal to 5 successes, but that's the complement of having less than or equal to 4 successes. And we just figured out the probability of having 4 or fewer successes is 449. So 1 minus 449 would be 551. A probability, then this is really the big thing I wanted to get out in this problem. The probability of an event is usually considered rare or unusual if that probability is less than 0.05 or 5%. So we'll talk about in later chapters, maybe chapter 8 and 9, we'll talk about the importance of that 5% cutoff. But usually when they're asking if something is unusual, they're talking about, is the probability smaller than 0.05? So in this case, I would say it would not be unusual because the probability is 0.551. So hopefully this all checks out. These answers were off by a little bit, but I was still close enough that all those got marked correct. So, but the main thing was I wanted to get at this word unusual and what the cutoff is for that. All right, guys, good luck studying for the test.